class, and welcome to our Chapter 6 review. So here's the first part. This was from Lesson 1. Hopefully you guys are able to remember this. Write each product, remember product means multiply, using an exponent. So write each product using an exponent. Dolan, how would I write 13 times 13 using an exponent?
13 to the second power.
13 to the second power. We can say 13 to the power of 2. We can say 13 squared. All the same thing. Lucas, how would I write 1/4 times 1/4 times 1/4 times 1/4 times 1/4 times 1/4?
1/4 to the power of 6.
1/4 to the power of 6. Excellent. Amelia, how would I write 5 times 5 times 5 times 5 times 5?
You would write 5 to the power of 5.
Perfect. And lastly, Ella, how would I write 6 times 6 times 6?
It would be 6 cubed.
Ooh, she said the fancy word too. 6 cubed, yes. 6 to the power of 3. All we do is count how many times we multiplied the numbers, and that's going to be our little number. Isn't it way easier? How many of you actually want to write out 1/4 that many times? Because I don't. I did not want to do it then. This is so much easier to write, and especially if we get really big. Imagine if I had something to the 16th power. You think I want to write that out? So that's why we use exponents. But now, I want you to write each power, notice I call them powers because it's to the power of, as a product of the same factor. Product means multiply. Marley, what would the first one be? 2/3 times 2/3. Excellent. Perfect. Ethan, what about the next one? What would that one be? So Delaney, what is it going to be?
0.8, 0.8, 0.8, 0.8 4 times.
Yeah, so we multiply 0.8 4 times. I'll make these dots look a little bit bigger. Exactly. We multiply it 4 times. Abner, what about this last one? 9 to the third, 9 cubed. What would I write?
You'll write 3 9s.
3 9s. Am I going to write 9 plus 9 plus 9, Abner?
Yeah.
What do we think? Thumbs up, thumbs down. What do we think? Abner?
No.
No, what am I going to write? 9?
9
9 minus? Does anyone want to step in? Romina?
9 times 9.
9 times 9 times 9. Perfect. Now, I just want to know, would it be okay had I written 2/3 times 2? If I had written 0.8 times 4, or if I had written 9 times 3? Would that have been okay? Thumbs up or thumbs down? Would that have been like okay? Totally cool? Right? No, thumbs down. Those are not the same thing. 9 times 9 times 9 is not the same as 9 times 3. No, those are not the same thing. When you're doing with exponents, is this, you are going to write that many times. And I remember times because now I'm multiplying. So these ones are not legal. No. I want you guys to solve this. Remember, we follow PEMDAS. Okay, Marjorie, I want you to solve this. What did you do first?
Okay, so first I do what's in the parentheses. So 5 squared is 25 minus 6 equals 19. And then I put...
So hold on, go slower because I'm doing this. So 5 squared is 25. And then she does minus 6, and she gets that to be 19. Then we just bring everything else down so far. Perfect. Next, what did you do?
Okay, so 12 divided by 4 is 3, which 3 plus 19 equals 22.
Perfect. She did it correct. Excellent. So a mistake that a lot of you guys would make is that you don't go in the right order. So you've got to make sure you know PEMDAS. Okay, Camilla, let's start. What did you do first?
First, I multiplied 25 and 2.
Perfect. So we do the parentheses first, and what'd you get?
I got 50.
Excellent. So I'm going to write out the whole problem right below again. because that helps keep it clean. That helps keep it in my head. What'd you do next?
Then I did 4 times 2 because of the exponent.
Perfect. We're following PEMDAS, parentheses, exponent. What'd you get?
16.
Perfect. Then what'd you do?
Then I divided 96 and 16 got 6.
Perfect. So then we got 6 plus 50 minus 15 minus 3. And then what did you get next?
I added 50 and 6.
Perfect.
6.
56 minus 15 minus 3. And then?
Then I did 56 minus 15.
Which is?
I got 41.
Perfect. So we got 41 minus 3. And what was your final answer then, Camilla?
38.
38. Excellent. So we see all of the steps that she did. We did parentheses, exponent. We did not have multiplication, but we do have division. Then we have addition and we have subtraction. Notice that I wrote it all out, and it's also kind of cool because as you see, look at that. It keeps getting slimmer every time because as we're doing it, we keep getting closer and closer to a smaller answer. This problem, I want you to use grouping to write and solve the problem. So just like we saw yesterday in the thing where we were buying multiple stuff, we can group it together to make it easier for us. So our question is, Ava went to a farm. She bought 4 eggs for $2 each, 3 gallons of milk for $7 each, and a pet chicken for $20. So I want you to group it together. I want to see a written expression and I want to see the answer at the end. So Lucas, first we have to use grouping, parentheses, that we're gonna do to write it out. So how did you group it?
First I grouped 4 and 2 and multiplied it together.
Perfect. 4 eggs for $2 each. That's 4 times 2. Then what?
Then I multiplied 3 times 7.
Perfect.
And then, I did 20 times 1, which is 20.
He did, and he wrote it like this, 20 times 1. He could also just leave it as 20. And what sign's going to be between all of these?
The addition symbol.
Yes. How'd you know it's addition? What's the key word we see in the problem that tells us we're doing addition?
Each.
Ooh, each is good. That's how we know we're doing multiply. And is how we know we're doing addition for the ones between it. So these ones, each means multiply. This one, each means multiply. And means addition. So what's 4 times 2, Lucas?
4 times 2 is 8 plus 20, and then plus 21, and then plus 20 gets you 49. But I actually didn't use a key word.
So Ben, what is the greatest common factor between 7x and 14? Perfect. The greatest common factor between 7x and 14 is 7. So I divide them both. What's 7x divided by 7? You get 1x. I'm just going to write an x. And what's 14 divided by 7? 2. Hey, that's our answer. That's the whole thing. Notice we still don't get a number. There is no number answer. We do not get a number. And we can check it with distributive method, the distributive property. I have to multiply it by everything on the inside. 7 times x gives me 7x. 7 times 2 gives me 14. And that's how we just checked our work. We just went, yep, those two are the same thing. Speaking of distributive property, I want you guys, as this one's right here, I want you guys, it's not the full answer right there, so don't look at it. I want you guys to solve these problems. Remember, when a number is touching a parenthesis, it means multiply. And not only does it mean multiply, it means multiply that number times everything inside. Okay, so Sophia, let's do the first one. What did you get as your answer?
Well, I'm not sure if it's right, but I said 7 parentheses x plus 63.
Said 7 parentheses x plus 63. Ooh, we're very close. We're very, very close. The answer would be 7x plus 63. So we no longer need the parentheses there. What I did is I multiplied 7 times x, and I got 7x. I multiplied 7 times 9, and I got 63. Perfect. Dolan, what about number 2?
That's what I got.
Dolan, what about this next one? What is 3 times 2x?
6x.
Perfect, 6x. And then what would the next one be? So then 3 times 4 is?
12.
Perfect. You always have that x. There is no more combining it. There is no more than that. Now this last one was hard, but Camilla did it. I'm stoked. Camilla, ready? Let's look at this one together. What is negative 10 times 5x?
So what I did, I ignored the negative sign and like just did 10 times 5.
Uh-huh.
So I put negative 50x.
Perfect. So she ignored the negative sign at first. She goes, okay, so it's 10 times 5, but then it's a negative. Then make it a negative. So she's perfectly correct there. And let me guess, did you do the same thing for the next one?
Yeah.
So what'd you get for the next one?
I got negative 70.
Negative 70. Excellent. So what happened is she just goes, okay, I'm going to put the negative sign there afterwards. I'm going to look at it afterwards. She knew 10 times 5 was 50, but it's negative. Then she knew 10 times 7 was 70, and she made it negative. So perfect. I want you guys to solve these problems. So I have decided that A is equal to 1/2. I've decided that B is equal to 15, and I've decided that C is equal to 9. All you do, it's called plug and play math. That's what I like to call it. Plug and play. We take those numbers and we just plug it in for whatever letter I say they meant. So Lucia, all I do is I'm going to plug in my numbers instead. What is C equal to?
9.
So I'm going to plug it in for C. 9 squared plus, and what is A equal to?
1.5.
1/2. So, Lucia, what is 9 squared equal to? That means 9 times 9. What is that? 81 plus 1/2 gives me 81 and 1/2. Vahe, let's plug them in together. So, I've got 2 times, because if they touch, it means times. What is A equal to, Vahe?
1/2.
1/2. And what is C equal to?
9.
9. So perfect. Vahe, do you know what 2 times 1/2 is?
2/4.
Ooh, that's yeah, 2, that would be close. So 2/1 times 1/2. I can cross cancel here. I can cross cancel out my 2's, right?
Yeah.
So that just becomes 1. What is 1 times 9, Vahe?
9.
There's our answer. So if I had made them all fractions, I would check with my cross-canceling, or I would get 18/2, which I can divide. 2 and 2 cancel to 1 and 1. Then I just cross multiply. I would get 1 times 1 times 9 is 9. 1 times 1 times 1 is 1. So 9/1, or just 9. Pearson, what about this last one? What is B equal to?
E is equal to 15.
So I put 15 squared minus 5, and what is C equal to?
9.
So do I write 59?
No, you have to times.
Oh, I'm multiplying, right, because they touch, so it means multiply. Perfect. I gave you a hard one. Do you know 15 squared? 15 times 15 gives us 225. Minus, and what's 5 times 9, Pearson?
45.
40.
225 minus 45, 180.
Perfect. And that is our answer. Write each sentence as an algebraic expression. What that means is that I don't know something. Who can tell me, Sebastian, what do I not know in this problem? What is the unknown piece of information? What do I not know? Go.
Juno's age.
Perfect. I do not know Juno's age. So Instead, I'll put a J or an X or whatever I want to use. That's my unknown. I do not know what that is. Who would like to tell me what my algebraic expression for this would be then? Who would like to tell me what my algebraic... Lucas, what do you think?
I feel like it would be like 12 minus J.
So he thinks it's going to be 12 minus J. Do I have anybody that has something different? I'm curious. Do I have anyone who has something different?
That's for another verse.
So he's close, but he's not fully correct. Remember, we see this word, less than. So that word than, in English, then means come after. So we apply that in math, than. It means I'm going to put this after. So less means subtraction, just like Lucas knew. I'm going to get J minus 12. And that makes sense. Let's say Juno is 20. I would do 20 minus 12 to find out what's less than. I wouldn't do 12 minus 20 to find out what's less than. It's that key word that you have to remember. Than means it's going to come after. So think about this one. This one's really hard. Okay, so Jessica, what is it that I don't know?
You don't know like how many kittens are like in the shelter.
Yeah, I don't know how many kittens are in the shelter, so I'm going to say that's K. So, Ben, what would my expression be? Yep. He says 1 over 2K, and then what? Minus 8. Perfect. We see 8 less than. Then we automatically know it's going to come after. 1/2 and of means multiply. 1/2 times the kittens in the shelter. I'm going to tell you how we can check this. Let's pretend, you guys, that there are 32 kittens in the shelter. I want to solve this. 8 less than 1/2 of the kittens in the shelter. If there are 1/2 of the kittens in the shelter, 1/2 would be 16. 8 less would be 8. Let's check it here. 1/2 times 32 over 1, and then minus 8. I would find that I can cross cancel, get 16. 16 minus 8 is 8. I just make up a number and plug it in as a good way to check, but if you don't understand what that was, then that's okay. I want you to match the expression to the property. Lucas, what's the first one?
The first one is identity.
Identity, because nothing changes. It has the same identity. Marjorie, what's the second one?
Commutative.
The second one is commutative, because it doesn't matter what order they do it, they're still communicating. So Sebastian, what is the last one?
Associative.
Associative, because even though they're in different groups, I can associate with different groups. I want you to simplify this by combining like terms. So first, I'm going to break this down with us. Ready? What matches with 12x? Who can raise their hand and tell me what term matches with 12x in this problem? So Camilla wrote in the chat, and she's almost fully right. She wrote 9x. Are you ready? It's negative 9x, because we have to include that minus in front of it. Lucas, what matches with 3y?
2y.
Perfect, positive 2y. And then lastly, we just have a 7. That's it. We don't have anything else. We don't have anything else. You want to know the easy way to do this, you guys? Here's how I do it. What variable goes in the yellow one? What variable, Delaney, what variable goes in my yellow circle? What variable goes in my yellow circle? Amelia, what variable goes in the yellow?
X.
X. I want to see then. Ruby, what variable goes in the green? Y. And the only thing that goes in the blue is we've got that plus 7. Let's do our combinations. So I have 12x minus 9x. That's just the same as 12 minus 9, keeping the x. On your fingers, what's 12 minus 9? On your fingers, what's 12 minus 9? Yes, we get 3. Then on your fingers, What is 3 plus 2? Because it's positive 3 plus 2 on your fingers. Perfect. 5. It's a positive, and then plus 7. That's my answer. 3x plus 5y plus 7. Do I have an answer? Do I have a number answer at the end? No! I still just have my variables. That's what my answer is. And on the last one, I want you to write this expression. Pringle bought 6 toys for X dollars each. 4 of the toys had a catnip add-on for $1 each. So I want us to write that. I'm going to give us a hint. It's probably going to look a little bit like grouping. We might have something that looks a little bit like grouping, similar to that. Let's break it down. Pringle bought 6 toys for X dollars each. How do I write that? Someone beat it to the full answer in the chat, so I'm calling on Eduardo. Eduardo, what is the answer?
6x and 4.
6x and 4, which means plus 4. Yes. Pringle bought 6 toys for X dollars each. That is my 6x, 6 times x. Then 4 of those toys had an add-on for $1 each. It would have been written as 4 times 1, but guess what? 4 times 1 is 4, because I would have wanted you to simplify it anyway. Let's say it bought it for $3 each. It would have been 4 times 3, which would have given me 12 if it had said $3 each. But it said $1. I got 6x plus 4. Excellent, you guys.